Today we're going to look at inequalities, specifically the notation of inequalities. Okay, so let's move on. So what is an inequality first of all, and what's it all about? Well, an inequality is a relationship between two numbers normally, or it can be expressions or algebra as well, where one is typically greater or less than the other. Okay, so that's really what an inequality is. It means that effectively one is greater or less than the other, and obviously we use a notation to kind of display that within mathematics. All right, so represented by the following notation. So these are the ones to be familiar with. You have this little arrow symbol, and that stands for greater than. Okay, then you have the little arrow symbol with a little line underneath it. That stands for greater than or equal to. So in this particular case, the two sides could be the same, but it'd be the same or greater than, essentially. And then you've got the flip side around, where you've got where the arrow points the opposite direction, which stands for less than. And then, of course, it kind of goes without saying, then if you've got the same arrow pointing left with a little line underneath it, it stands for less than or equal to. Okay, something to kind of note is that the inequality tends to, well, it does, points towards the smallest value. All right, so it points towards the smaller value. Something to kind of bear that in mind. Okay, so it typically in mathematics, obviously, there are going to be questions in relation to using inequalities and understanding inequalities, and you may be asked to find integers that satisfy inequalities. Well, integers are whole numbers. And of course, the terminology is the one to be kind of be mindful of here. So if you're asked to say which integers satisfy an inequality, all they're really looking for is the numbers which satisfy it. So we'll look at an example, it'll probably make more sense, and normally just put them as a list in order, ideally, away from the value that is given. Okay, so if you're asked to write down the first three integers that satisfy inequality x is greater than 5, then we're looking at the first three whole numbers which are bigger than 5. All right, so reading the inequality, x is greater than 5, and of course we're now looking just to identify what those are, just so literally just count up from there. Okay, so the next number up is 6, and then 7, and then of course 8, and that is your first three integers which are greater than 5. Okay, well, what about if you've got three integers that satisfy this particular inequality? Well, the first step is obviously reading this. Well, you can notice we've got the little symbol here, which is line underneath. So this is less than 2 or equal to. So x is less than or equal to 2. So that's the first step, is read it. And because it can equal to, we're going to start with that particular number. So we're looking for the integers that are equal to 2 and then go down from there. So we're going to start with 2, and then we're going to go down to 1, and then we're looking to go down to the next one, which is 0. All right. Now your question may be here, is 0 an integer? Yes, it is. All right. So 0 is classed as an integer. All right. So you could argue, well, it's not a whole number, but it is classed as an integer. All right. So that is something to really kind of be mindful of. All right. So there we go. So 2, 1, and 0 are the first three integers that satisfy the inequality. X is less than or equal to 2. Okay. So what about if you've got an inequality where you've got x in between two particular numbers? All right. So here we go with this particular one where you're asked to write down a list of numbers that satisfy the total inequality. Well, you are limited here. So in the previous part, we were asked to identify the first three because you could carry on. But when you've got an inequality such as this one, where you've got a number one side, a number other side, and two sets of inequalities with x in the middle, what you're saying is you are limited to the number of integers that fit in between them. All right, so as before, we're just going to read the inequality. So x is greater than 1. All right, so that's the first bit here. X is greater. You'll notice it's the other way around. If you're going to read this the other way around, you would say 1 is less than x. But if you're reading it back to front, x is greater than it. So the bigger number where the open bit is greater than 1, and it is less than or equal to 4. All right, but you'll notice this idea that it's in between these two. So anyway, so it's greater than 1 and it's less than or equal to 4. So we're trying to think about going up ideally. So we're going to start off, well, what is the number which is greater than 1, and then count up until we get to the number which is equal to 4. All right, because we've got this inequality. So we're going to go up. So 1 doesn't count because it needs to be greater than that. So we're going to go for 2, and then we're going to go for 3, and then of course because it says equal to 4, we're going to have 4 as well. Okay, well, let's just have a look at another one. So write down the integers that satisfy this particular inequality. In the same kind of idea, we've got the same kind of numbers things going on here, where we've got a number this side and a number this side and x in the middle, but this time you'll notice the inequalities have kind of changed, where we've got less than or equal to on this side, and then just less than the 2. So we're going to read that inequality. So x is greater than or equal to -2, but less than 2. Alright, so counting up like we did before, because it can equal to -2, we're going to start with -2, then we're going to go up -1, and then 0, and then 1, and of course because it says less than 2, we cannot include 2 in this particular one, so that is our set of numbers for that particular case. Alright, so that's inequalities, and that's the notation. Just a case of familiarising yourself with it, and of course making sure you understand when it's equal to or not. Alright, well, thanks very much for listening.